Good evening, everyone present in this meeting. Let us welcome once again Ajay sir for his third session in this IIT JAM Mathematics lecture series. Welcome, sir, and I invite you to start your session. Thank you.
Okay, thank you, ma'am. So, good evening to one and all present here. So, this is your third lecture for this series 2026. So, in today's lecture, we will cover orthogonal trajectory, Cauchy-Euler equation, and in next lecture, we will discuss about the variation of parameter and Wronskian approach. So, orthogonal trajectory. What do we understand by orthogonal trajectory? Orthogonal trajectory it is a curve which cuts every member of a one-parameter family of curves at a right is called orthogonal trajectory of family of curves. Now we can see this as a one-parameter family of curves. You can say circle as x square plus y square is equal to some c square. So here one parameter c, which can take values like if I fix c as 1, it is x square plus y square equals to 1. Then if I put c equals to 2, then it is something like x square plus y square is equal to 4, and so on. So basically, a parameter parameter family of curves. So orthogonal trajectory is just a curve which is perpendicular to this whole family. Like here we can see this line, which is nothing but an which makes an angle 90-degree with this family of curves. So here, so now orthogonal trajectory, if we go for slope, so we can say if I have a one family of curves, one parameter, sorry, one parameter family of curves, then we know the slope. What is slope? Anyone? If I have this equation x square plus y square is equal to c squared, then how do we find slope?
Differentiating with respect to x, d
Okay,
dy dx is the slope.
yeah. So slope is nothing but dy by dx, right? Now we are finding orthogonal trajectory. So it is nothing but the perpendicular family of curves. Say orthogonal, which is orthogonal to the given if that family is M2, then what is the relation between two curves when they are M2 is equals to,
-1.
yeah. So here we go with this concept. So what is working rule? So if we are given a family of curves fxy, so I have defined like m1 m2 equals to -1. So what was m1? M1 was dy by dx dot m2 equals to -1. We have to find the family of curves which is orthogonal to the given curve. So the what we say, The slope of the curve we are finding is nothing but minus dx by y dy. So here, what we do, if we are given a family of curves as fxy equals fxy and c is some constant, that is we are considering as it as a one parameter family of curves fxy is equals to 0, then what we do the differentiation with respect to x to form the corresponding differential equation. And what we have to do we have to eliminate the constant c from the equations c, whatever the differential equation. Then what we do the replacement of dy by dx by minus dx upon dy, and then we get a new differential equation. And then solving that first order differential equation, we get the new family of curves which is known as orthogonal trajectory for the given family of curve. Same if we go with the polar form. If some in polar form we have equation in form like r equals to f of theta comma c. The c is constant, theta is angle, and r is radius. Then again we have to differentiate with respect to theta the whole equation, differentiation with respect to theta. Then we have to eliminate the constant c, and then we have to replace dr by theta by minus of r square d theta by dr. And then whatever the differential equation we get, we have to simply integrate and find the solution for that differential equation, which is the new family of curves, which is nothing but orthogonal trajectory with respect to the given curve. So now we have some examples. So here first given is we have to find the orthogonal trajectory for the set of hyperbolas as xy equals to a. So what we have to do next, first step was nothing but we have to differentiate with respect to x. So it is nothing but x of dy by dx plus 1 into y equals to 0. So here the constant is automatically removed. So what we can write as x dy by dx is nothing but minus y. What was the next step? It is we have to replace dy by dx by minus dx upon dy. So here it is x minus dx by dy. Why we are doing this? Because we have to find the orthogonal trajectory with respect to the given family xy equals to a. So here we can simply write x dx equals to minus y dy. That is nothing but x dx minus y equals to 0. So now we can simply integrate. So this is nothing but x square by 2 minus y square upon 2 equals to some c, constant of integration, right? Or simply we can multiply the denominator part in left hand side to the right hand side. That is x square minus y square is equal to k. K is nothing but 2c. So this is the orthogonal trajectory for the given curve xy equals to a. Is that clear to everyone?
Yes, sir.
Okay. So now we will work with another
Sir,
example.
when we require in polar form finding, I think in Cartesian form it is easy to understand and easy to do because we have only replaced the dy dx in terms of minus dx by dy. But in case of polar form, I think this formula or working rule is quite different in looking. Uh, in
Okay.
how can we uh,
Yeah, how can we?
recognize this which procedure polar form or Cartesian form should apply?
The equation, the given set of equation you have to rectify. Like this is in a simple Cartesian form, right? X and y.
Yes,
If it was given in some form of like this r square cos square theta plus r equals to k, if the given equation is in this form, then you can't like go back easily. Like you have, if you have to go to this Cartesian form to polar form, you can easily like what you have to do, x equals to r cos theta and y equals to r sin theta you have to put, right?
yes, yes,
And you can go to polar form. But if it is in given polar form, you like sometimes like here it is simply it is some y square plus, yeah, it is y square plus root x square plus y square equals to k, right?
yes,
Oh, sorry, it is x square. Okay, so here
yes,
you have to again do some multiplication, and it will be a lengthy process if the given equations are compact form or complex form, you can say in polar form.
yes,
So you can directly go with this formula. Like you have to find dr by d theta, and simply you have to put a replacement of dr by theta by minus of r square d theta by dr, right?
yes,
Yeah. So it is given in the equation, in the questions itself, like whether you have to use the polar form or you have to go with the Cartesian form. Fine.
yes, sir.
Okay. Okay. So here it is. We have to find the orthogonal trajectory for the given family y equals to c x to the power 5. So how do we approach? We simply differentiate this equation with respect to x. This is 5 times c x to the power 4. Now, can you eliminate the constant c? Anyone?
So C is equal to y by x to the power 5.
Yeah. You have to use this c is equal to y equals to x to the power 5. So here dy by dx is nothing but y by x to the power 5, x to the power 4, which is nothing but 5y by, right? Now, what you have to do? Replacement dy by dx by, so it is minus dx upon dy, 5y by x. So nothing but x dx plus 5y dy equals to 0. So nothing but x square upon 2 plus 5y square upon 2 equals to some constant, say k. For a, it is nothing but x square plus 5y square equals to no constant. So this is the orthogonal trajectory for the given family, right?
Exactly.
Okay. Now we are having this family of curves, which is orthogonal to the family gxy equals to l, where k and l are constants. We have to determine gxy. What it is saying that we have to find gxy. So, and what it is given, the family of curves, which is orthogonal to the family gxy equals to l. So what it is nothing but orthogonal trajectory for with respect to this curve. So simply we have to find what is our orthogonal trajectory with this respect to this curve. So this is what we do in first step. We have to differentiate with respect to x So it is nothing but 2, 1 minus y. First, we are doing differentiation of x, and then we are doing the differentiation of next term. And next, it is minus dy by dx equals to 0. You can remove 2 from all equation. And what else? You have to replace dy by dx to minus dx by dy. So what you do? 1 minus y minus this this negative sign, if we use here, this will become positive, and this is dx by dy equals to 0. What is the next step? It is nothing but 1 minus y dy plus dx equals to 0. What you have to do? You have to simply do integration to find solution of this differential equation. This is y minus y square by 2 plus x square by 2 equals to 0, equals to some constant a. This is what you can write: x square minus y square plus 2y equals to a. So this is the orthogonal trajectory. So here it can be taken as L. If we compare this, so L is some constant. So here I am taking a, so it is treated as constant. So what is the value of gxy? Gxy is nothing but x square minus y square plus 2y. So it is clear to everyone till now?
Sir, I have not understood this point. It is given that 2x minus 1 minus y is equal to k is the orthogonal to the family of g of x y. Okay. Can we
Yes.
tell conversely, g of x y is equal to L also is orthogonal to this family of this one, previous one.
Mm-hmm.
Yes, and that is why from the explicit form of the previous one, you will find dy by dx at first.
Mm.
I think differential equation of the first one.
Yes.
And getting after getting differential equation of the first one, just replace minus dx by dy because that will form the g of xy. Okay.
Yes. Yeah.
Okay. But sir, if I start from g of xy, then it will be complicated. Okay.
Then it will be complicated.
Because we don't know the form of the g of xi. Hardly you
Yeah,
can
yeah, yeah. You can
g
do
dash,
one.
and after that g dash, after that dy dx maximum of. uh,
Okay.
mm, okay,
Also, you
okay.
can do
Thank you.
one thing, one more thing,
Huh,
that here you can simply write it in a simple form like y minus 1 to the power whole square. If you like add remove a something minus 1, something minus 1. So it can be treated as new constant, right?
yeah.
So simply you can like further, if it is like some options are there like x square minus y minus 1 whole square is equal to a is the, like if we say it is the given in the options, then it is also the correct one.
Okay, sir.
Okay.
Okay.
Okay. Now there are some important families of curves, like you can directly uh, remember these results. Like if we go for solving, it will take some time. So you can take screenshot of these forms, like I have written here. It is to like you can directly cram these results. So if we have parabola of uh, form having y square is equal to 4x, then orthogonal trajectory is ellipse. Okay. And next, if the parabola is of form this type, 4x plus a, then orthogonal trajectory is, it is same. So yeah, it is also called a self-orthogonal. Okay. And next, there are polar results. If I have r equals to a times 1 plus cos theta family, uh, family of curves which are of these forms, then we are having a orthogonal trajectory with the replacement of sign plus to minus and minus to plus. So in same case, if we have a in place of cos theta, if we are having sin theta, then it is again in plus case, the orthogonal trajectory for that curve will be r equals to if I say r equals to a 1 plus sin theta, then its orthogonal trajectory is r equals to b 1 minus sin theta. Okay, if we are having families of curves of this type. Otherwise, if in second we have a family of curves like of this type, Rn equals to some a to the power n cos n theta. Then it's a orthogonal trajectory r of type form. Like here we have to replace cos by sine, and same in case of sine, it is cos. Okay, and again one more type of form, that is sine Rn into some sine n theta equals to some a. Then it's orthogonal trajectories directly of, you can remember these results, as if we try to solve, this will take us some time.
Sir, what are self-orthogonal trajectories?
Self orthogonal trajectory is like it is orthogonal to itself actually.
So I mean, how
If
to
if
understand by equation
uh,
that it is self-orthogonal?
equation, it is self orthogonal, that you are solving this this is the given family of course, right?
Hmm.
And if we find the orthogonal trajectory with respect of this, then what we have, the procedure, we have to find dy by dx, then you have to eliminate a, then you have to replace dy by dx by minus dx by dy, you get a new differential equation. And if you solve that equation, solve that differential equation of first order, and you get the same curve, you are getting the same curve type in orthogonal trajectory, then it is said to be self orthogonal. The constants are need to be changed because it is a parameter. Okay.
Hmm. Okay, sir, got it.
Yeah. In all of cases you can see like we have changed the constant again in this form as well, you can see. Now this is the question of IIT JAM exam of 2014. So here what it is, like the value of a for which the curves intersect orthogonally. So what do you, like, what will be your approach? Like anyone can tell. So like here one curve is given there and another curve is also. So it is
Uh,
they intersect orthogonally, means they are in particular this is some orthogonal trajectory to this curve, right?
so we will find dy dx for both the curve,
Yeah,
and then, sir, since they intersect orthogonally,
yeah,
so uh, m1 into m2 is equal to -1.
yeah, yeah, yeah,
From
you
there
got
we
the
can
point.
find the from there we can
Value of
find the
a.
value of a.
Okay. So if I take this curve and find dy by dx here, so it is, I'm simply differentiating it with respect to x. It is 2ay dy by dx equals to 0. So here, what is dy by dx? It is minus of 2x upon 2a. That is minus of ay, x upon right? And what you have to do, you have to like replace dy by dx as minus dy. Oh, okay. You can find here the what you find slope. So this is dy by dx is equal to 2x. This is m1. This is m2. If I say so, what is m1 multiplied by m2? It is minus 1. So here it is minus x upon 2y. So the ay minus x upon ay into 2x is minus 1. This is nothing but minus 2 of a y x square equals to minus 1. So simply what we get here, it is ay equals to 2x square. And we have the y equals to x square. Like this is the intersection point. So it satisfies both of the curves equation. So we can use y equals to x square here. So it's ax square 2x square. So we get a equals to 2a. So correct option is D. So is this clear to everyone?
Yes, sir.
Yes.
Okay, fine. So now we move to second question. So simply here we have to find the orthogonal trajectory of the family of the curves y equals to c1 x to the power cube. So you can try and tell me what will be the correct answer to this question.
Option D, sir.
Option D. Okay. Any other option? Like I get one response as D. Any other like some other option as answer? Okay. Let me solve again. So we have not done like I can solve. So here it is dy by dx. Simply we are differentiating with respect to x. It is c1 to x square. And what you have to do, you have to eliminate the constant. So it is c1. I can write y equals to x cube from here. So it is nothing but dy by dx equals to 2y by x cube x square. It is dy by dx 2y upon x. What you have to do to find the orthogonal trajectory, you have to replace dy by dx by minus dx upon dy. In next step, so here you get 2y by x with minus x dx 2y dy. It is nothing but square by 2 minus of pi square plus it is plus. So did I mistake? I am mistaken somewhere. Okay. So can anybody tell where I had made mistake? Can anybody tell where had I made a mistake? Like, are you guys are involved? Like, anybody can answer?
Yes, yes, in line thing.
Yeah, here I have made a mistake. Like it was c1 x to the power
Three,
cube. So it should be 3. Okay, so I can simply replace this by 3, 3, and again it is 3y square by 2, which is it is something 3y square plus x square is equal to some new constant. Okay, so the answer is D option. Okay, is it clear to everyone?
Yes, sir.
Okay, now we have next question. So this is given family of asteroids which is having equation as this thing. So you have to find orthogonal trajectory. So what you do, you simply differentiate with respect to x. So it is 2 by 3 x to the power minus 1 by 3 plus 2 by 3 y to the power minus 1 by 3 dy by dx equals to 0. And you can simply remove 2 by 3 from here. And what you can do in the next part, dy by dx, as simply you can write minus of y to the power minus 1 by 3 x to the power minus 1 by 3. Okay. So you have to replace dy by dx by minus dx upon dy, which is minus x minus 1 by 3 y to the power minus 1 by 3. So becomes x to the power 1 by 3 dx equals to y to the power 1 by 3 dy. It is nothing but 1 by 3 x to the power 4 by 3 equals to y to the power 4 by 3 plus some constant c. So what you can write it as x to the power 4 by 3 minus y to the power 4 by 3 equals to some new constant k. So here the correct option is B. So with this question clear to everyone?
Yes, sir.
Yeah, fine. So now next question, we go for next question. So okay, simply I am not solving this question. You guys have to solve and tell me what is the orthogonal trajectory for the given curve. So like anybody has solved what is the orthogonal trajectory with respect to the given family of curves?
So y is equal to c root x.
Y equals to C root.
C root x.
Okay. So like is there like any student who are getting problem in getting orthogonal trajectory as y equals to C root x? If like there is any, I can tell like how we have to solve this to get this orthogonal trajectory. Or should I proceed with the next part of this question? Should I need to tell you how we get this as our orthogonal trajectory curve? Okay, I'll tell you like in short what we do. We have to do differentiation with respect to x. So it is nothing but 4x. Then it is 2y dy equals to 0. dy over dx equals to 0. Then it is dy y dy equals to minus of 2x dx. It is y square by 2 equals to minus 2 of, okay. Now we have to replace this dy by dx minus dx of dy 0. So it is 4x plus 4x minus 2y dx over dy equals to 0. So here it is nothing but 2x equals to 2y. 2x equals to y dx upon dy. It is dy upon y equals to dx upon 2x. So what we should write it as log of y equals to 1 by 2 log of x plus c. So it is nothing but you can simply write, you can take this new constant as log c. So it can be written as log of y equals to log of x to the power 1 by 2. We all know if we have this thing and log of x, it is written as log of x to the power n. So we are using here, it is 1 upon 2. So the power is taking a log, x is taking power as 1 by 2 plus log c. And we all know what is log x plus log y. It is log x y. So here it is log y equals to log of x 1 by 2. Taking antilog, what we get? Y equals to c x to the power half, which is nothing but c root x. So is that clear? Like how did we get orthogonal trajectory as y equals to c root x to everyone?
Yes, sir.
Okay. Now let me erase this part. So now what is given next? Now it is given that if C belongs to S and the curve C passes through the point 1, 2. So C, the curve C passes through the point 1, 2. So what we can find, we can get value of constant here. C is some curve. Okay, let's not confuse. I am taking A as a new constant. So if the it is taking C as some curve that passes through point 1, 2. So it satisfies the uh, equation of the new curve, that is a new orthogonal family, or we can say orthogonal trajectory. So it satisfies point 1, 2. So we can find a value of A from here. So at x equals to 1, y is taking value as 2. So it is 2 equals to a root 1. So what is value of a? A is 2 from here. So what is our full equation of for the orthogonal trajectory? It is y equals to 2 root x. Now here are the points. We have to also check that C also passes through which of the following of these points. So we can directly like we can directly put these points and see whether the given points are satisfying the family that we have find so far. So we can check. So from option A, it is x equals to 4, y is root 2. So what we are getting, if I put x equals to 4, what we are getting, y is 2 into 2, it is 4. So at x equals to 4, y is 4. So this is not the case. Like we can remove this option and this option because at x when x is 4, y is 4. So both options are neglected. Now we have to check for value of x equals to 2. So what if I put x equals to 2 where it is y is taking value as 2 root 2. So this option is neglected and C is the correct option. So yet C is the correct option which also passes through this orthogonal project. So this question is clear
Yes, sir.
to everyone? Okay, fine. So now we are having next question. So like what is the equation of orthogonal trajectory to the given family? It is passing through 1 comma 1. So can you solve for what is the orthogonal trajectory for this family of curves and tell me the last step? Like anybody have solved? Okay. So let me do this. So we are given this family of curves. So first step is differentiate with respect to x, which is a dy by dx equals to k of dy by dx. Simply you can remove k from here. So from here, what is value of k? Take it. Okay. And next thing is like you can simply try it 2y dy by dx, or you can simply take this right hand side. It is 2y plus k. Okay, and it is 2x equals to dy by dx, 2y plus k. 2y plus k is taken from here minus y square upon y. Is dy by dx equals to 2y squared, that is y squared plus x squared upon y 2x. What is the next step? We have to replace dy by dx minus dx by y dy, which is nothing but x minus dx upon dy y squared plus x squared upon y. Okay, next you simply multiply this thing to x y dy. Cross multiplication 2xy dy equals to minus of x squared plus y squared dx. Next it is x squared plus y squared dx plus 2xy dy equals to 0. So we get a differential equation. Now we have to solve this equation and find the orthogonal trajectory. So like till now, up to this point, like whatever we are doing is correct, like understood by everyone. Like till this part, everything is clear to everyone.
Yes, sir.
Okay. Next, I'm just erasing this thing. So now what we are having? We are having first order differential equation, and we already studied like the method, like separation of variables and the exact differential equation type. Can we do, like, can we check whether the given differential equation is exact or not? And we simply like can relate and find the solution. Yes or no?
Yes, sir. Sure.
Yeah. Yeah. So what we do, we have to find del m upon del y. What it is? It is 2y, and del n upon del x. What it is? It is again 2y. So we can see the this given the equation is exact. So simply we can write the solution, general solution for this. So what was that? It is something m dx plus n terms free from x dy equals to some constant y here treated as constant, right? So here we are taking x square plus y square dx, and next terms free from x, and so here we consider this as 0 equals to c. Here y treated as constant, so it is nothing but x cubed by 3 plus y square x equals to c. So this is the orthogonal trajectory of this family of curves. Now we have to find value of c as the given family is passing through 1 1. So here if x is 1, y is 1. So what we can say directly, c is something 4 by 3. Okay, so c is some 4 by 3. So which one is correct? Answer. First one, or you can simply put here c as 4 by 3. You simply get y square x equals to 4 by 3. So by multiplying by 3, this is the solution. This is the correct answer. So this question, like the solution part, is clear to everyone.
Yes, sir.
Okay. So now I have two more questions. You can simply take a screenshot and try by yourself, and we can cover the Cauchy-Euler equation type in this session. Now you can take screenshot of this equation as well to try it your own. Now we will look what is Cauchy-Euler equation. So when we are having equation of type of this type, some x to the power n, it is in general form. If I, it is in operator, directly written in operator form. If I look it in simple form, so it is nothing but dny of dxn plus some a1 xn minus 1 dn minus 1 y over dxn minus 1 plus up to a n x d plus a n minus 1 a n d a n equals y. Or you can simply write it as dy by dx plus a n y equals to some function x. This form of equation, when we are having, we have did what we have did, we have looked over differential equation with constant coefficient in last session. So here one, like you can say some power x into some dy by dx. Here if I am having a derivative term of nth order, so multiplying it as it by x to the power n. So what you have to do, simply you have to take a, if we put, you can simply directly you have to replace x d by d, x square d square by d d minus 1. But how you get this form? So simply you are putting x equals to e to the power z. So you are substituting x as e to the power z, and you are having operator dy by dx. So what it is dy by dx? So you can simply take, if I write dy by dx as some dy into dz, or dy by dx as dy by dx multiplying by dz. So I am multiplying it by 1 actually, and I am taking dz as here. So it is dy by dz and dz by dx. So what it is, if what I have make a substitution of x as e to the power e z. So simply what can I write? Z equals to log x. If I differentiate this with respect to x, so it is dz by dx is 1 upon x. So what it is? It is actually dy by dx equals to dy by dz. And what is dz by dx from here? It is 1 by x. So you are simply writing that dy by dx, x dy by dx equals to dy by dz. So simply, if you go for this x square d square y by dx square, what you get? You get it as dy by dz, dy by dz minus y. Okay. So simply, if I take left, if I'm considering here left side, so here left hand side is operator d, which is derivative of something like I have to consider dy equals to capital D y. It is something different, which is d by dz. Right hand side is derivative with respect to z, and left hand side it is derivative with respect to x. So here I am making a replacement of some like a form x to the power n dn. So here it is x to the power 1, t to the power 1 is simply replacing by capital D. And next, x to the power square d square, it is d minus 1. Similarly, what you have to do for power n, you have to go d minus 1 up to power d minus n minus 1. That is one power less. So here it is x square, so you have to consider up to one power less, that is d minus 1. When you are having x cube, so you have to consider d into d minus 1, d minus 2. So simply you are having x to the power n dn. Simply you are going d minus 1 up to one power less of n, that is d minus n minus 1. And then you will simply converting this equation into equation with differential equation with constant coefficients. And then you solve the equation and you get the solution in, you will get, now you are converting this, you have to solve the equation of considering this type d by dz, any dy by dz, some d square y by dz z square, and you are getting, you will get solution in form of y as function of z. Then final solution, what you have to use, you have to simply use z equals to log x, and then you have to convert the final solution you are getting into as a function of x. So next, so this I have tried to explain like how we approach in this case, and now we will solve one example. So I think it will be much clearer to you. So here it is given x square equals to x square into some d square y by dx square plus x dy by dx minus 4y. So it is in Cauchy-Euler form. So what will be our approach? You have you have to make a substitution x equals to e to the power z, or you can say simply z equals to log x or ln x. So here you can simply, what you have to replace? You have to replace xt by new d, that is d by dz. Right hand side d by dz and left hand side it was d by dx. And x square, here what it is, in operator form you can write this equation as x square d square plus x d minus 4 of y equals to 0, right? And here it is, you have to replace x square d square. So here you have to replace xt by this new d, and x square d square by d up to one power less, that is 2. So we have one less power, that is d minus 1. So simply replacing d minus 1, then xt to d minus 4 of y equals to 0. So now you are dealing equation in some d by dz. So here new operator form, you are getting solution in some function of z, y as function of z. So here it is d square minus d plus d minus 4 of y equals to 0. So it is some d square minus 4 of y equals to 0. So this is the differential equation that we need to solve, and this is a differential equation with the constant coefficient, and we have already gone through this in the last session. So how we solve? We simply write the auxiliary equation m square minus 4 equals to 0, and we look for roots. So it is plus 2 plus 2. So what is the solution? Y is some c1 e to the power 2. Now we are dealing with d by some solution y as some function of z. So y equals to e to z plus c2 z into e to power 2z. And now what we have to do? We have to use z as log x. So I can simply replace z by log x and e to the power z as x. So it is nothing but y equals to c1 x square plus c2 z as log x into x square. So this is the final solution for the given differential equation. So like this part of solution is clear to everyone till now. Yes or no? Like anyone can reply.
Yes, sir.
Am I? Yeah, okay. So now we have to do next question. This is similar type. You can try it your at your own, and also I can solve this simply in short form, whatever I have explained to you. So it can be written as this. What you have to mix up new substitution as d minus 1 minus 3d plus 4. After substitution x equals to vz, we are dealing with d by dz here in operator form. So this is something like this. We have d square minus d minus 3d plus 4 of y equals to 0. It is d square minus 4d plus 4. It is something d minus 2 ka whole square again. 2 to the, yeah. So again, what we are having, we have to write auxiliary equation. So it is m minus 2 whole square equals to 0, which is m is taking value 2 to complementary function. Again, it is this of the same type, same roots, same real roots. So we have to simply write e to the power 2z plus c2 some multiplying it by z e to z. Again, writing the final solution in form of x. So it is c1 x square plus c2 log x into x square. So again, this is the final solution. This is like similar to the previous example. Okay, so thank you. Like if anyone, any student have any questions, like at some point he can ask if there is any kind of doubt. Hello.
Participants, are there
Yeah.
any queries? So, shall we wrap up, sir?
Yeah, man.
All right. Thank you so much, sir, Ajay sir, for this engaging session. Looking forward to your fourth session tomorrow. Participants, thank you for attending so patiently. See you all tomorrow, same time. Thank you.